Thank you so much for giving us the opportunity to represent our project. We have done the design and analysis on a V12 engine mechanism. Our main topic was parametric modeling and functional analysis of a V12 engine mechanism. We are group six, so we have like five people in our group. Myself, Shamsul Amin, my LUID is L20608349. So I'd like to request my group member Muhammad Sheikh Saad Habib Rasul to present the next slide.
Myself, Sheikh Saad Habib Rasul. Today, I'm briefly explain that to talk about our project modeling about a V12 internal combustion engine using Fusion 360. This project focused on designing a fully functional V12 engine. Our goal was to replicate the mechanical realism and motion dynamics of the key components. Using Fusion 360, we carried out parametric design, joint simulation, and motion analysis. The project also emphasized manufacturability and ease of assembly and continuous improvement throughout the design process. Uh, Now, our next slide. Uh, in the assembly phase, we created a completed 3D model of the V12 engine. This included essential components such as pistons, crankshaft, connecting rods, and the engine block. We used different types of joints, rigid revolves, and slider to simulate the motion of the engine. Importantly, the engine was designed to accommodate 12 pistons with an alternating flirting configuration accordingly mimicking real-life internal combustion engine operation. Now, our next slides is present our group member Nakul Bakshi.
Hello, sir. My name is Nukul Bakchi. My LID is L20622155. Now I'm going to talk about the overall view. So this is the project exactly looks like when we open that in Fusion 360. Now we can have the two views here, the northeast isometric view on the left side and the right side. It's the side view of the overall project. Now I'm going to next slide, which is the exploded view. So when we open up the project, it will exactly look like this. Inside the project, it's the crankshaft, which will move when we play the project. Now, this is about the parts of the models and how it functions. So we are going to talk about the key parts and their rules. So we used their piston, which converts the combustion force into motion, and we used connecting rod, which transfers motion from piston to crankshaft, and we used crankshaft, which converts linear motion into rotational energy, and finally the engine block, which houses cylinders and supports overall assembly. So this was about the all parts. Now I'm going to move to our another group member named MD Jobair Rahman.
So, hello, this is MD Jubair Hussain. My LID is L20616364. So, I'm going to talk about the parts we used in the simulation. So, as you can see from the first part is connecting rod and the second part is piston. So you see that we have used utilize the Fusion 360 to like smoothening our connecting rod and like piston to conjunct in the V12 engine. So now I'm going to talk about the manufacturing plan we had for piston because as you said, we only did the piston in CNC programming milling. So we use the aluminum alloy for thermal conductivity, for heat resistancy, like like V12 engine will produce so much heat, so it will help us to reduce the heat as much as possible. So then we do the CNC machine programming, like with groove cutting and bore drilling and finishing with like scallop. So the tolerances, to talk about the tolerances, tied on diameter and pin bore for durability and heat resistance. As you know, like engines produces so much heat, so it will be like more sustainable. So now I'm going to talk about the justification. Like it will improve if we do the suggested like improvisations with the machine. It will improve their balance, weight, and like functionality. So next slide. So right now I'm going to talk about the CNC operation on piston in Fusion, like manufacture part. So here what we did, like for the piston ring group, we use 2D contour to like drill the side of the circles, and then we did like bore drilling to do the like cylindering shapes to like shape them accordingly. Then we used scallop for like finishing touch. So that's the only three program we ran for this piston to improvise. Thank you. Now my next partner Alvi will tell the rest. Thank you, everybody.
Go.
Thank you so much for giving me the opportunity to speak again. This is Shamsul Amin, LUID L20608349. So the main purpose of the design is to understand the Fusion 360 software, how we're gonna design the things, how we're gonna manufacture the process, and how we finally convert our design into a sustainable machining process. And to do so, we've had to analyze the design manufacturing, and our initial challenges was overhanging recesses and uncut made machines costly. High material removal rate, increased cycle time. As you know, the V12 engine has a lots of piston, and it makes lots of horsepower to run any significant machine. So it creates lots of power. So that's the challenges we are facing during our drawing and so on. So we have got some improvement that can be done. We have flattened down our geometry to improve the efficiency of the machine. We introduce ready straight of sharp internal corners to make sure there is no edges, spark and so on, so that the functionality can be higher of the machine, and simplified skid profile for a better CNC access. Actually the idea is to have a generic V12 engine manufacturing process, so that we can show our expertise that we are good at drawing the lesson that you have taught us so far in Fusion 360. Next slide, please. So design of our assembly analysis, that is like something we have gone through theoretically, what we will assemble and how we're gonna do it. This is a very big engine, so we have done the piston CNC operation just to make sure that we know how to do it. Tighten clearance fit and complicated piston rod alignment, as we have corrected it to make sure that the engine can be run smoothly. We misaligned the wrist pin holes caused in insertion difficulty. We also minimize those problem as well. So our solution is very simple. We want chamfered pin entrance for easier fit. We improve the groove geometry, which by which we have the access to move the machine here and there to make sure that the holes and everything, the pistons and rod can be connected perfectly, so that the synchronization rhythm can be there very effectively during the assembly. Next slide, please. So there actually we did not redesign anything. We have just improved the V12 engine functionality. We had our idea that we will make a V12 engine where it will be a generic engine where every part can be covered. Based on that, we have done some CNC operation as well. But to do so, what we have considered in our mind to optimize the piston design, which can reduce the tooling wear and setup time, that can be done more effectively. As we are very new in Fusion 360, if we have more chances, we can redesign this idea based on those piston design, and we can reduce our time as well. We can improve we improved alignment features, speed up and simply assembly. Also, there is a chance that design changes improve both productivity and efficiency for sure, because this is a most important dynamic engine for automobile industry. And the same way, the visual comparison of sketch and of improved design is recommended here. That's how we can improve the V12 engine in our next work. But right now we have only completed the CNC operation as per approval that we have taken from you. Next slide, please. And that's the summary. That's we come into the last slide of our presentation. We actually demonstrated, we understand how we're gonna use Fusion 360, and we understand how we're gonna manufacturing the process and how we're gonna design the things. We emphasize on our visual and functional accuracy in engine design, not only the engine in design, in 360 design. There we can right now design the wheel, the air fresh, whatever the thing is, that the simple thing we can design. And because we have a very clear understanding of DMF and DFA idea, that actually help us to redefine ourselves so that we can understand how the real world production can be done. And finally, we understand the CAT principles and industrial engineering principle, thanks to you, that you have taught us the whole process with so dedication and practical assessment. Although we could have done much better, but we have tried our best to make sure that we understand the course, and as a group we all give our best effort to learn how we're going to use the Fusion 360 software. And that's all from our side, group 6. Thank you so much, sir. And we sincerely appreciate your time and attention. Thank you so much for giving us the opportunity to showcase our work and our learning journey. And I'm pretty sure this is the beginning of our CAD/CAM journey, and we will come back to you for more understanding in coming days. Thank you so much on behalf of group 6. That's our presentation.